Hey guys! So today you and I are going to talk about fixing things in a topological way. So let's get into it. So the question in question was basically a follow-up on a description that I made on a question that I have handled already, where the question was basically, Frederick, how do you fix a legacy system? And basically the way that I do it, or my technique for doing it, is, as I've told you before, it's really down to taking an inventory of the code and then doing what I call a topological priority of how to address all the issues and creating a long-term plan for how to fix it. And so the question, of course, is, can you describe what that means in practice? Well, it's very simple. So to give you a very, very concrete story for how I've done this the past few times, let me tell you sort of what made me go sort of from the person who like I used to just do software development, and today I'm usually the go-to for most of the managers or the people in the past few roles I've had has basically all been about one thing: take over, fix everything, and basically lead, and not just tech leading stuff, but basically take responsibility for the entire delivery process. And my career sort of shot up after people started to realize, or that my managers realized that I could actually do this, and because it is very difficult, and I'm not going to claim that I'm the best at it, but I have a system or a way of doing this that seems to work fairly well. So to give you a first example, I started working on a project where basically the managers at the time, they needed to raise the quality of the system, and they did not really have a strong faith within the current setup of the team, and they didn't, when it came to actually delivering on the long-term goals, they didn't have any technical leadership. It seemed like most of it was people working as consultants and so forth, and they didn't really have any product managers and so forth who could handle all of the aspects that are necessary. And this touches on something that I've said in the past, where basically what I claim is that if you want to, in a permanent fashion, handle a software project, you need not just a product manager who has some idea of like what we're going to build. You actually need a technical representative who has the same level of understanding. You basically need both soft skills and tech skills, because the reality is, guys, that some teams are not going to have the composition of developers that are necessary to deliver on the goals that they need. They will need someone to coach them. This is the thing that I keep telling people. This idea that you can have managers who are non-technical and then reach the same level of results as you might do in like the top IT companies is just hilarious. It's not going to happen. It is, as I said, it is like having a general who's never been to war. In some cases, leadership is necessary at a high level, and you sort of go hands off with your leadership because you need people to sort of do their own thing. But that is only when they actually know how to execute and do the thing that they need to do. You can't do that if they need coaching and so forth, which is the incompetence that I have talked about many times, where most managers or most technical leadership engineering managers, it's a joke how little they actually know on how to take a team of mid-level software developers and turn them into highly productive productive software developers. So when I did this, the topological thing I was talking about is that the first thing I need to do is to figure out what are all the things, doing the code inventory basically, and figure out where are the problem areas. And this comes from experience, where you've worked on so many projects that you know what the systematic problems are. First thing I see in the project is, for example, alright, so, and you don't judge people. This is the important part. You don't go in and tell people you're doing that wrong or this wrong or so forth. You just observe. That's number one. Just try to figure it out and do the thing that I usually tell people, at least the tech leads, the other tech leads that I've talked to, is to just say, take this standpoint. You weren't here when all of this happened. There could have been a million things that was going on. You don't know why the state is what the state is. It's sort of like, to me, I look at myself as a little bit like a cleaner or something like that. I come to this frat party or something like that, and it's like everything is a mess, and I go, yeah, this is shit, and it's gonna take some time to clean all this up, but I'm paid to clean it up, not to ask why did they have such a wild party, because they are clearly not thinking about me when they did this. They were doing their own thing, so now I'll just do my job, which is to clean this stuff up. And so I take a look and I see that most of the stuff is fairly straightforward. They don't have a structured work process. They don't use basic Kanban board or anything like that, and they have quality issues related to a lot of regressions, a lot of bugs, a lot of fear and anxiety related to the release process, all these sort of classic things, which is systematic issues that causes that people lose faith in the system. And I look at the code and I see, all right, it's mostly a mess. They don't have any unit tests. They don't have any reviewing process really, like they're just ad hoc pushing things and stuff like that. The developers are not really syncing, like they're not really talking to each other. They're just doing their own thing. They're not using, in this case, they were working on a front-end application. They're not modularizing their code. They don't have a clear architecture for like how to structure the different pieces of logic, like a classic one. Front-end developers who quote-unquote are full-stack developers, they have usually a very poor understanding of how to use basic things like MVC, or like these concepts where you segment and create a single responsibility between different layers of an application, like data fetching, view and presentation layers, logic layers, and so forth. So they sort of just bunch everything together because they lack that, right? So I make a list of all the things that I see that we're going to need to fix this based on my experiences working on multiple projects at this point, both front end and back end and full stack, and I've done tons of stuff related to this in different companies, which is sort of the thing that I've told you before, guys. This is not something you do as a junior, because you simply will not have seen enough projects to sort of figure out what sort of architectures and things that you need in order to reach those goals, right? And then I see that the first thing I need to do is that, all right, here is we talked about the topological thing. So they're using a tech stack that is not what the company wants them to use. But the problem is that we can't just migrate the entire tech stack because the code is so coupled, so spaghetti, that we're not going to be able to do that. So I know that, all right, the first thing I should do now is to introduce two small changes. The first thing is that I'm going to make sure that they do a stand-up, and I'm going to make sure that they start writing unit tests and that they have a reviewing process of that code. The reason why I want to do that is because doing the stand-up means that they need to start communicating with each other and align on who's doing what, so that we can actually get in reviews, because if they're not accustomed to talking to each other, it's going to be more difficult for them to collaborate on code reviews and doing these sorts of things, which is going to be necessary now that we're going to start looking at, say, unit testing. Now, the reason why some of them said, oh, well, do we really need unit testing? And I go, no, not necessarily if you know that everything is working all the time, but it's not. So you are expected to write unit tests now. And what happens is what always happens. The code is in such a state that it's difficult and painful to write unit tests, and I know that because that's the reason why I want that to happen first, because now they have to think about how they architect their software in a better fashion, which means that by just introducing that, they now have to start asking the question, how do we actually write code in such a way that this is possible? And now I can go in and help them, coach them into saying, all right, if you start segmenting your code into view components and logical components, or you may have heard of view and container patterns and things like that, you can make your experience writing tests much easier. And that starts off the process of moving things into a better structure. Now, for example, moving to a new tech stack, well, that's going to be difficult. So what we need to do is to establish a basic layered architecture of the different for the application, where, say, data fetching, which is now like these ad hoc network requests they're doing, well, that's not going to work because we can't really test for that. We have a lot of issues related to fetching data from an API that doesn't get validated correctly, or the request goes out in an incorrect fashion. We get bad data models. All right, so let's take a look at that. Then we move all of our ad hoc network calls and all these models that they have created. Well, basically just they do this thing that front-end developers always do, like they fetch data from the network and they just pull that into the entire application. They don't have no layer between the entire application and whatever came from the network, right? So what we do is that we, as I said, we start with simple unit tests, which now makes them wonder, okay, so how do I test that request that I sent to the database? Like, how do I test the data and stuff like that? And I show them it's easy. Let's move that into a REST client, like a handwritten REST client. We don't have to do anything fancy, and let's use basics. In this case, it was just snapshot testing to make sure that the network request actually looks correctly, and then you just create an interface. And it's probably a good idea for you to create that interface that basically aligns with what's coming from the network, but we should not move that into the rest of the code base, because we should map that into a data structure that we actually need, because that ties into how we write our visual components, because our visual components will be simplified and easier for us to deal with if we create an interface from the inside of the component that exposes towards the outside, and then we can do a mapping between the data we're getting and the stuff that we expect on the client side to consume. And so what happens is that it starts this is the topological thing I'm talking about. I can't get to the big refactor of because they were using a framework that they weren't supposed to be using, basically, and management wanted a different one. I can't just do that immediately, because what's going to happen is that we're just going to have to undo this gigantic ball of mess, and that is too much work up front. So what we do is, as I said, to just look at what pieces do I need to get in place and start moving before I can unblock that big thing. Within just a few weeks, we had gotten, and this is happening on every story basically. We don't have to say, and some of it had to be dedicated, as I've said in this explanation that I had, that usually you can Boy Scout this if you create a plan with the team and sort of show them how to reach those goals, and then you set milestones. I told them, first thing first is we create an API folder. When we have all of our network requests in that folder and it's well tested and it's well documented, so we know that we have a good data layer, then we will move on to the business logic. We will create services that do the mapping and creates all the data structures that we need to consume on the UI. And when that's done, well, then basically there is no coupling between, in this case they were using Nest and the management wanted Next, then there's no coupling between that framework and the new one. It's just all JavaScript, and the business logic is safe, it's tested, and it can basically be pluggable. You can put that in an Express app for all, it doesn't matter, right? It doesn't matter which server you're using. And within a few weeks, this was done, and now moving basically all of that logic came over to, and then they asked me, okay, so how are we going to move to this new framework or this new thing? And I said, it's very easy. So we're going to create a load balancer between these basic servers, and you're going to be able to connect to both of them. One is going to forward the request to the old system, and one is going to forward to the new system, because they connect to the same backend APIs. And now we will move each endpoint one by one, because we don't have to sit here for weeks and weeks and weeks and do like this gigantic rewrite and stop feature development. And that's a topological way of dealing with it, guys. You don't just pick the thing that seems to be most important. This took a bit longer than it would have if you just sat down and rewrote it, but the journey there was more impactful, because during that journey, the developers learned how to take care of their own code base, like with testing and like sort of the impact that has. They learned more about how to and we got an architecture that will scale. And finally, when it was time to do that big investment to do the thing that was actually very costly, the cost was almost nothing, because all the work that led up to the time up to that point had basically reduced the cost down to almost nothing, and there was a clear roadmap of what the end state was. And then we delivered that thing. And by the time this actually happened, guys, I didn't even need to coach them anymore, because they could finish the last thing themselves. And last I checked, now they're trying to figure out, okay, what are we going to do next? Because all their issues were gone. Literally, all of the these things that management was unhappy with was gone. At least when for the part that I'm describing. There are other things, of course, to this story, but that's the main takeaway, I think. So what I want you to take away from this is that a topological way, or what I call Boy Scouting with a plan, is basically just it's just a way to approach dealing with the big problem. It's basically divide and conquer, but you do it in such a way that you have to figure out in what order do I do the things that I want to do in order to minimize the cost of each thing I'm doing. An iterative approach. Sometimes you have to sit down, and this was the case for a lot of the business logic and so forth, you have to sit down and rewrite some stuff, but you don't just willy-nilly start pulling on things. You try to figure out where are the underlying problems, and then you try to sort them in the order that you need to address them in order to make each thing as cheap as possible. Because you can start on the big behemoth rewrite immediately, and that's going to be super expensive and very error prone and risky and so forth. Or you can understand that, legacy code is, as I like to say, it's a systematic problem. It's not something that just happens. It's not code doesn't just rot. It's something that is happening with the developers themselves. In this case, the problem was that they didn't really know how to create a good architecture. So that is something we need to address. We also need to address the collaboration. We need to address the way that they do peer reviews. We need to address their understanding of unit testing and good component design. Because if we don't address those things and create a joint understanding for how to do things, we're just going to get back to the same problem again. And that creates a story with actual milestones, just as any project. It's just that it's at the code level. And it becomes almost a combination of an education for the developers how to do things and a path forward to a better state for the code base. And all it takes is for you to figure out what are the steps that I need to take and pick the thing that is easiest to start off with, that is going to unblock and lead to the next improvement, and then the next thing, and then the next thing. And when you get to those big things, you're usually going to find that they are not so complicated anymore, because you changed the state of the code little by little until the big rewrite or the big thing is just one little box that you need to tick. Have a great day.